Okay, in this section we're solving equations. So here you see your steps for solving equations. Simplify both sides, get the variables on one side, constants on the other. Isolate the variable and solve. So here's our first one. You'll see it's really busy. There's a lot of stuff going on. It's way too busy to solve right now. So first of all, we need to simplify both sides. So I'm going to distribute this 4 through, and I'll also distribute this 3 through, and that should get rid of our parentheses. So 4 times 2 is 8. 8x plus 4. That's going to be a 29 here, and then I've got 6x minus 15. Now it's still way too busy, but at least we don't have parentheses in there anymore. Okay, the next thing that I'm going to do, I'm still on that simplify step. I'm going to combine like terms. So I have a 29 here, and I have a 15 here. 29 minus 15 is 14. You'll notice that I didn't change any signs, I didn't change any sides, I didn't move anything over. I just literally said, I have 2 like terms here, let's put them together where I don't have so many terms on this page. So that leaves me with an 8x plus 4 equals 14 plus 6x. Just bring that x term down. Now that does finish step 1, simplify both sides. So step 2 is to get variables on one side, constants on the other. It doesn't matter which one you move first. I'm going to move this 6 first. So to get rid of it, I'm going to change its sign. So instead of a positive 6, I'll put a negative 6, and that would cancel it out. So this leaves me with 2x plus 4 equals 14. From there, of course, I'll move the 4, and 2x would equal 10. Divide both sides by 2, and finally we'll have our answer, x equals 5. That's how it would look. In this section, you have 2 different types. You've got equations with fractions and equations without fractions. So now we'll look at the ones without fractions. There's a big difference between these two, and I wanted to point that out. In this one over here on the left, the denominators do not contain radicals. Let me say that again. The denominators do not contain variables. Now, I just misspoke. Unfortunately, I've been teaching radicals all morning, so I have radicals on my mind. But I meant to say the denominators do not contain variables on this type. Let's make this one blue. Over here, the denominators do contain variables. Now that's a big difference there, and it's going to cause us to have a few more steps. Okay, so let's talk about over here on the red side. My denominators are 4 and 3 and 6. All I have to do is get a common denominator and work it from there. So for this one, the numbers that 4 and 3 and 6 all go into the number 12. So my least common denominator for this one is 12. Oops, didn't mean for it to be yellow. Sorry about that. Okay, my common denominator again is 12, and that's because 3 and 4 and 6 all go into 12. Remember complex fractions in our last section? What we did with those complex fractions is we put the LCD in every top, and that's what we're going to do here too. I'm going to put a 12 here, I'm going to put a 12 here, and I'm going to put a 12 here. Now I'm allowed to do that because I multiplied on the left side of the equals by 12 and the right side of the equals by 12, so that's why that's allowed. Now if you look at this first term right here, that's going to give you a 12x over 4. And if you look at the second one, 12 times 2 is 24. That gives you a 24x over 3. And over here, this gives you a 60 over 6. Well, 12 over 4 is just 3x. And 24 over 3 is just 8x. And 60 over 6 is just 10. And so now we no longer have fractions, and now it's really easy to work. So, looking at this one, I want to get my x's on the same side. I promise it's easier if you move the 8. So I'm going to subtract 8x from both sides, even though that's the bigger one. So I'm going to get negative 5x equals 10. Divide both sides by negative 5. And x would equal an answer of negative 2. And that's how that one would work. You'll say you just started this page by talking about denominators not having variables. Well, if your denominator does not have a variable, all you have to do is start with the least common denominator, put it in the tops, simplify it down, and get your answer. It's really easy. But if your common denominators do contain variables, you have to go through the domain step. Remember, exclude numbers which make the denominator equal 0. Now you didn't have to do that in the other one because 4 and 3 and 6 were all numbers. They couldn't be 0. But if you have a case where you have an x in the bottom, you have to do that exclude step. Okay, looking at this problem again on the right side, my denominator, the only one with an x, is x minus 2. So if I say set x minus 2 equal to 0 and I solve that out, I get that x equals 2. From our study of domain in our last section, you know that we have to exclude this. X cannot be 2. Now what we know about that is that's not in the domain. If we plug 2 into this equation, we would get something over 0. That means we have to throw that out. My answer cannot be 2. You'll say, well, what can your answer be? Well, that's our next step. If you have variables in the denominator, make sure you include the avoid step. Change that. This answer, in other words, this answer cannot be 2. Right, so let's see what our answer can be. Let's start back over. My equation is x over x minus 2. 2 over x minus 2, and 2 over 3. Now that we've done this avoid step or exclude step, we can work it just like we did the other one. We need to get a least common denominator. So my least common denominator for this particular problem has a 3 and it has an x minus 2. So I'm going to put a 3 and an x minus 2 in every top. 3 and x minus 2. 3 and x minus 2. 3 and x minus 2. Okay, take your LCD and put it in every top. Now then, this x minus 2 right here is going to cross out and it leaves you with a 3x. This x minus 2 right here crosses out and it leaves you with 3 times 2, which is 6. This 3 crosses out here and it leaves you with a minus 2 times x minus 2. Now it's easy. That's the easy part at this point. You don't have any more fractions and all we have to do is simplify out this green equation. Get rid of parentheses first. Remember, two negatives are going to make a positive 4. On this right side over here, you have like terms, so we can simplify that. So we get 3x equals 10 minus 2x. 6 plus 4 gives me the 10. Okay, I'll go ahead and move my 2x over. So when I move my 2x, that's going to add 2x to both sides. So 5x would equal 10. I'll divide by 5, and x equals 2. We think, yay, that's a great answer, a really good number. But remember, from the top, my answer can't be 2. It's not in the domain. So since my answer cannot be 2, this answer for this problem is no solution. Okay, remember, if it has an x in the bottom, you have to do that exclude step, that domain step. Since 2 was not in my domain, it cannot be an answer. And so my answer here would be no solution.